Hey guys, it is Campbell here. This time I've got a question from a local coach who I have helped out a little bit in the past, asking about 6-motor drive bases using blocks. Now if you're familiar with VexCode V5, then you know that you have the option to do 2-motor and 4-motor drive bases, but not 6-motor. So I'll go ahead and show you that now. You see I've got this 4-motor drivetrain. There is the option to do 2-motor, but because I've already added a drivetrain, obviously I can't do that. So over on the left here in my drag and drop section, I've got this drive forward, turning, setting the stopping, setting the velocity, all those fun sorts of things. Unfortunately, this is a little bit more difficult when you're using a 6-motor drivetrain, because you sort of have to make the drivetrain code, the drive forward, the turn functions yourself, so to speak. But in this video we're going to be focusing on this drive forward, this just real simple one. I've made a video on drive functions before if you're interested. That was text coding in C++ with VexCode V5 Pro. So check that out if you'd like. But I promise this is going to be a lot more simple than you may think. So let's go ahead and get started. Alright, so to start off with, I'm actually first going to be giving you the sort of the mathematical justification for why we're going to do what we're going to do, and then I'll try and explain it step by step, as we're programming it. But here's sort of the math behind it. So I encourage you guys to learn this. If you haven't learned it already, it's super important later on. So we're going to start by just drawing our wheel here. So this is the one of the wheels on your robot, right? We'll say that we have a 4-inch wheel. 4 inches is pretty common for use in competition and with Vex in general. But regardless of the size of your wheel, you want to figure out this your circumference, which is just the entire distance around your wheel, right? Now, for our sake, we can just assume the wheels are perfectly circular. I know they're not, but it gives us a close enough estimate, right? So if you've got a 4-inch wheel, I'm going to be honest, I prefer to work in centimeters, so I'm going to convert these to centimeters. If you don't know how, 4 inches, you just multiply that by 2.54 to get, 1 second, I have it written down because I'm not going to do it in my head. 10.16 centimeters. And then so let's change color here. To get the circumference, all you do is just multiply your diameter here times the constant pi. You have probably heard of it. Some of you have probably used it already. That is 3.14 roughly, and so this will give us 31.91858 centimeters, and that is our circumference. So that is 31 point. Let's change colors again here. 31.91858 centimeters. And the controllers that are built into VexCode V5, you probably know, you can spin the motor forward a set number of degrees, right? So we know that one full rotation of a circle is 360 degrees. I'm not going to use the degree symbol. Seeing the unit makes it easier when you're like doing math with it and stuff. So 31.9185 blah 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 centimeters over 360 degrees. If we simplify this, which means just divide the top by the bottom, you are going to get 0.08866 centimeters per 1 degree. So if this is 1 degree, then this distance, we'll use a different color so it's more obvious, this distance here is going to be 0.08866 centimeters. Okay, how is that useful? Well, we know that we want to travel a number of centimeters, and we want to go this number of degrees to do it. And so that has to equal this ratio right here. So it has to equal 0.08866 centimeters per 1 degree. Now this should be familiar to everyone. You can cross multiply. Some people call it butterfly method, right? So cross multiply and you get you get number centimeter degrees. Oh, whoops, actually don't need that. And that is equal to 0.08866 times x centimeter degrees. We can just leave the units off for now. Let me go ahead and erase that just because it looks sloppy. And so that means to find x, which is our variable, right? That's the one that we want to find, the number of degrees that you're going to be turning. That is, at the most basic sense, that's what we want the function to do. You know, we put in, you know, I'm going to drive 6 inches, I'm going to drive 12 inches, I'm going to drive 13.5 inches, right? We do that input, and what we need to do is make a drivetrain that figures out how many degrees do I turn the motor for that, right? So that's what we're trying to find here, x in degrees, how many degrees we turn the motor. So all we do, very simple algebra, we just divide the number, you know, of centimeters that we want to go. What was that? Was I using inches earlier? Excuse me, centimeters, because they're the better unit. We divide this number by 0.08866, and so that is centimeter degrees, and the 0.08866 is centimeters, and so the centimeter units will cancel out, and you get number divided by 0.08866 degrees equals x, and that works because we need x in terms of degrees. So all this messy stuff over here to say that basically all we need our function to do is we've got our input in centimeters, and we want to convert that input into degrees, and so all we do is just divide that by 0.08866, right, and that will give us our output in degrees. So hopefully that makes sense. Now we're going to hop on over back to VexCode, and I'll show you guys how to do that. Right, so the first thing you want to do is, unfortunately, you cannot use a drivetrain, I know, because the maximum they go is 4 motors, and we're using a 6-motor drivetrain. So I'm going to go ahead and delete that. Make sure you've got your controller if you are planning on using this for non-autonomous, for driver control. But I've got my 6 motors here, my left 1, 2, 3, my right 1, 2, 3. First thing that you need to do is come down to my blocks, and you need to make a block and add an input. I'm going to name mine drive forward, and then this number is going to be in centimeters, right? Okay, so here it says define drive forward centimeters. Okay, so what we're going to need to do is we're going to have to use an operator, right? we said that our input in centimeters has to be divided by 0.08866. Right? So here's our divisor operation. We're going to use centimeters, and we're just going to input that number, 0.08866. And then here is going to be the annoying part. Oops. We need to spin these motors forward for that number of degrees. And we have to do that for all 6 of our motors. So that's 6. So left 1, left 2, left 3, right 1, right 2, right 3. Okay, and that's all there is to it. So this is our function, drive forward a number of centimeters. Oh, we do have to repeat this block. And so what this block is doing is it's taking this input, right? So a number of centimeters, and it is taking that input and dividing it by that 0.08866. And again, that number is only for 4-inch wheels. If you're using 3.25 or 1.25 or 6-inch wheels or anything other than 4-inch, it's going to be a different number that you need to calculate for yourself, but just in the same method that we did previously, right? So now you do when started. Let's grab our forever, head down to my blocks. When we do drive forward, we can set this to be 20, or we can set it to be 30. And in theory, as long as we've done everything right, this should move your entire drive base forward about a foot, right? 30 centimeters. Now this is the same way that you will make any of your functions, so I'll go over turning functions as well. You would make a block, add your input, or if it's a true or false, or if it's a string, pick whatever it is. Probably it's normally going to be an input, and then it'll make this block, and you just have to define everything that it does, and then you'll be able to drag and drop that anywhere you need it. So unfortunately, that is the simplest way to make the simplest function with a 6-motor drivetrain. Maybe in a future update, VexCode v5 will add a 6-motor drivetrain, but it's really not too complicated, and honestly, personally, I recommend doing it like this, using your motors individually. I think it's just, you have a lot more control over them. You can individually set the speed of your motors. That's just the way that I prefer. But yeah, if you're going to use a drivetrain, it's definitely easy for autonomous. It makes it simple like this, where you just set your drive forward function. But honestly, if you're going to go through all of this effort, they might as well be individual motors already. Anyway, once again, I am going to be doing a turning function in blocks using a 6-motor drivetrain. If you would like to see anything else, please let me know. I hope this was useful. Yeah, thank you.